Hello everyone, today we look at the circuit of a disconnection alarm. Through this circuit, we can understand the role of one-way controllable return and its triggering conditions. First, let's take a look at the composition of this circuit. This circuit mainly consists of a battery pack, a power switch, a resistor R, a diode D, and a one-way controllable. It consists of an active wind detector and a thin wire. This thin wire serves as the triggering device of the alarm. When the wire is artificially damaged, the wind detector will sound an alarm. Let's analyze the working principle of this circuit. When the power switch is closed, the battery pack passes through the controllable return circuit. If the active wind meter is connected in series, then the wire in this place is in a closed state under normal conditions. This point is directly connected to the negative pole of the battery, so it is zero amplitude, that is, low level. At this time, the controllable gate spine will remain in the cutoff state because it does not get the trigger voltage. When the wire is artificially damaged and cut, the positive spine of the battery pack provides a trigger voltage to the controllable gate spine through the resistor R and the diode D. When the controllable gate meets the trigger conditions, it will change from a cutoff state to a conductive state. At this time, the active wind regulator will generate. It emits an audible alarm and is controllable. It has the trigger function of maintaining the trigger voltage. When the trigger condition is reached, even if the trigger voltage at this point is removed, it will maintain the conductive state. If this section of wire is damaged and then artificially closed, the voltage at this point will be restored. It becomes zero amplitude. But since there is a diode here that will isolate the controllable door ridge from this point, even if the wire is connected again, there will be a diode that will isolate the controllable door ridge from this point, so even if the wire is connected again, the controllable door ridge will not be turned on. If the state changes to the off state, then in this circuit, only when the power switch S is turned off and then closed again will the controllable reset change from the on state back to the off state. Then the conduction condition of the controllable return is when the gate ridge, also called the control ridge, satisfies a minimum trigger voltage for each type. The trigger voltage of the controllable signal is different as long as its lowest value is met. Then there are two cutoff conditions. One is the door ridge grounding and the other is the door ridge grounding, that is, it becomes 0 volts. At this time, the controllable return will reset and become cut off. The other is to change its current. It is to disconnect the power supply S to change the current, and then the controllable return will be reset when it is connected again. Next, let's demonstrate it with a simple object. The on. E on the right is a lithium battery of 3.7 V. The fully charged voltage of the lithium battery is about 4.2 V. This is the power on. This is the resistor to G tube. The switch to G tube used is the N4148. This is an active fan. It is a built-in sound source. As long as the appropriate external voltage is connected, it will make a sound. The middle one is controllable. Its model is MCR100-8, which is a 292 package. What is the order of its pins? When this model faces you, the 3 pins are on the far left. The cathode K is on the far right. The anode A is in the middle. The gate ridge G is also called the control ridge. So let's demonstrate below. First, turn on the power switch. Since this wire ESA short section of the gas wire is now connected, so the wind lifter has no sound alarm. Next, we cut this wire, and when the wire is cut, the wind lifter will sound an alarm. At this time, if the wire is artificially connected, Then this wire will, if it makes a sound, the controllable cabinet will not turn into a cut-off state, and the fan will continue to make a sound. At this time, only when the power switch is turned off and closed again, the controllable cabinet will change from the conductive state to the cut-off state. So the controllable cabinet mainly acts as a switch in the circuit. Compared with relays, its cost is relatively low, and it is a switching element with no outlet. When it is turned on and off, it will not produce sparks and interfere with surrounding electrical appliances. So in this place, the middle position is like a diode symbol. So what about a one-way controllable cabinet? It can only be used in a DC circuit, and the unidirectional current can only flow from anode A to cathode K, and in turn is cut off. Even if the trigger condition is reached, it will not conduct. So if you want this controllable cabinet to control alternating current, you can use a two-way controllable cabinet. So a two-way controllable cabinet is a current. It is directionless, but the two-way controllable cabinet is used in AC circuits because the AC signal will cross zero, so it does not maintain a state after being turned on. Once the trigger voltage is removed, it will immediately return to an almost cut-off state. This is a good video. Thank you for watching. Goodbye.